Welcome back, explorers, to another episode of Virtual MOSI. This is Weather Week, and today we're going to talk about something very, very special: pressure. Now, believe it or not, there's pressure on you at all times. If you were to make an OK sign and put that anywhere you like on your body, that's the equivalent of 15 pounds of square inch everywhere on you. We don't think of air as weighing a lot, but when it goes all the way up to space, it can actually build up a lot of weight and a lot of pressure. So watch what happens. I want to show you the effect of weather. I put a little bit of pressure, I put a little bit of water in this can, and as you can see, it's boiling, the steam is going up, and that's forcing a lot of the air, a lot of the mass outside of the can. And then I'm going to dump it into the water. What do you think is going to happen if I have a mostly empty can and then I put it into the water? Well, let's see. Are you ready, explorers? 3, 2, 1. And as you see, our can imploded. Our bodies don't do that because, of course, they are not empty. They are full of blood and guts and bones and all kinds of other good stuff. Take a look at our human body episode if you're curious to find out more. And pressure is one of the main 3 ingredients in all weather. Those are pressure, water, and heat. But what does pressure have to do with weather? Well, I have a jar here, and it's pretty easy to squeeze. It's not under a lot of pressure. But what I'm doing is I'm using this little bike pump at the top to put more and more air inside of this bottle. And you can build one of these at home yourself if you have a 2-liter bottle and a bike pump. And in the bottom, you'll see I put a little bit of a liquid. Instead of water in this case, I just put a little bit of rubbing alcohol because that vaporizes a little easier. And I'm adding pressure to the bottle, adding pressure, adding pressure, adding pressure. And it's something like a clear day. Have you ever listened to the weather and heard the newscaster perhaps talk about it's going to be a high pressure day today or it's going to be a low pressure day today? Do you know what that means? Well, right now our bottle is under very high pressure. What kind of day do you think it would be? You can see me through it, right? On a high pressure day, you're going to have beautiful, gorgeous, clear weather. But on a low pressure day, and I'm going to open the bike pump in just a second, watch what happens to that weather. 3, 2, 1. Clouds form. Isn't that awesome? So what happens is on the low pressure days, you have lousy weather, and as I pump more air into this and create high pressure again, you can see that you get clearer and clearer days. This is in relation to temperature a bit, so all of that air pressure causes the water molecules to kind of sink down, but when there's very low pressure, that water has a chance to rise and go up, like so. Okay. Now, there's another interesting phenomenon that pressure has to do with besides cloud formation, and let's explore it a little more. So I have what's here called a Bernoulli bag. Now, how many breaths do you think it would take me to fill up this whole balloon? I do a little bit of running myself, but I'm no Lance Armstrong. Let's see, if I were to try to blow it up, maybe 3 breaths, let's see. Not too shabby. More than my lungs for sure. But let's make it interesting, explorers. Do you think I could fill it up in 1 breath? Let's give it a shot. All right, this time, instead of putting my mouth right on the bag, I'm going to stand back a little bit, and let's see if that impacts anything. Ready? 3, 2. It actually works much better if you have someone holding the other end. But that's about as same as it took for 3 breaths to fill up the bottle or the bag the first time. So what's going on here? Well, by holding my mouth further away from the opening and blowing a fast stream of air, I created a lower pressure. Now, if all of those air molecules are being blown out of the way and spread out, that gives space for other air molecules to rush in, right? The universe likes a balance. So the air molecules in a high pressure, where they're all crowded together, want to go where there's more room, just like we like to spread out, right? So, by creating that fast stream of low pressure air, all the air in the room like to rush in, and it helps me fill that bag so much easier. Let me put this up here. Let's try it one more time. 3, 2, 1. Awesome, right? All right. Now, believe it or not, there's a scientist who explored this principle called Bernoulli. And not only did that help explain air molecules moving from areas of high pressure to low pressure, do you know what we call that in weather, by the way? Wind, when air is moving from one place to another. But Bernoulli realized that this had a bigger impact. It actually worked for all fluids. When you change the velocity, you change the pressure of the fluid. And this allows us to harness air power for a very special principle, flight. So let's check it out. I have this leaf blower here, and I have a bunch of beach balls. And we're going to see if we can use a fast stream of air to create lift, to see if we can get what those balloons in the air. Are you ready? It's going to be a little loud. Here we go. Oops. Need to plug it in first. It came undone there. Okay. 3, 2, 1. Allowing all the air in the room to rush in and help us lift that beach ball. It's not just this leaf blower that's lifting it up, it's actually all the air in the room. And I have one more demonstration for you guys here. If you happen to have any of this lying around and you don't need it, you can do this experiment. So, I have some toilet paper here. Where do you think we need to point the fast-moving air to get this toilet paper to lift off? Should I point it above, or should I point it below? Put in your answers while I re-plug in here. Alrighty, there we go. Did we get any answers yet? Above, below? Let's test it out. That's above. Did you notice what happened? When we had it below, it lifted off quite a bit better. Oh, excuse me. When we had it above, it lifted off quite a bit better than when we had it below. This is the same principle as what you might find on an airplane wing. It's shaped so that we can control the speed of the air flowing above and below and create lift. So, pressure, very important for weather, very important for lift. I hope you've learned something today. Try out some of these experiments at home safely. And as always, keep discovering.